Hello guys, welcome back to the channel. So in today's video, we're going to continue with our GraphRAG series of building GraphRAG from scratch using Neo4j and a CSV file. So in this tutorial, we're going to focus on building an ETL pipeline that's going to automate the whole process of loading our CSV files into our Neo4j database. So in the last video, let's look at what you've done in the last video, right? So which is just a project overview. So in the last video, we were able to read a bunch of CSV files, did some pre-processing on these CSV files, and then you're able to insert these CSV files inside of our Neo4j graph database, right? So once you insert the data, we had something like this. So I just opened the console, the Neo4j Aura console. You can see this is the data that we inserted from the last video. Okay, so this is what you have done so far from the last video, right? Inserting this data into our Neo4j database. But we have done all this using more of manual approaches. So with our ETL pipeline, we think we're going to automate all that process of doing basically the extract, transform, and loading data into our Neo4j pipeline. Sorry, into our Neo4j database. So we create an ETL pipeline to automate all these processes and make it very easier for us to do. And to do that, you're going to also use Docker to achieve the same. So we have a bunch of CSV files, right? So we're going to use Docker containers to run our ETL pipeline. That's going to go ahead and insert the data into our Neo4j. So that's what we'll be covering in this video, right? So read the CSV files, use the Docker container to run our ETL pipeline. That's going to go ahead and insert our data into our Neo4j database, right? Graph database. Okay. So let's look at a bunch of things that we'll cover in this video. So we're going to look at we're going to reset our Neo4j, right? Back to blank, right? Our database back to blank so that it has no record in it. So if when we run our ETL pipeline, you can see the data actually being inserted into our Neo4j database. So we're going to also set up our ETL directories, writing our ETL code using Python. Okay, and we're going to go ahead and create a simple bash script that's going to go ahead and execute our Python code. That's going to be basically the Python code that has the ETL code within it, right? ETL pipeline code within it. Once we are done with that, you're going to go ahead and create a Docker file, and this Docker file is going to go ahead and execute the bash script that you're going to create. And then you're going to go ahead and have a Docker compose file that's going to go ahead and help us create all these containers and all that from the Docker files. And then you're going to go ahead and query the inserted data, understand the different relationships, write a bunch of sci-fi to interact our data inside of our Neo4j database within the Aura console right here. Okay. So after that, you're going to go ahead and look at the different schemas that have been generated and get an overview of what we have done so far, right? And then finally, you're going to go ahead and conclude, and then we'll move on to the next, talk about what you're going to be building in the next video. Okay, so this process this whole series of videos is going to take you from very beginning, right, absolute beginner, to more advanced, or let's say intermediate user in terms of building RAG graph applications using Neo4j, right? Okay, so let's get started with it. So the first thing we're going to go ahead and do is to reset our Neo4j database back to blank, right? So to do that, you just go in here. So if you go in here, click on this right here, and then click on reset to blank, and then click on reset. So once this is done, if you go back in here and you refresh this, you should see all these relationships and all these nodes should not be there anymore. So just give it a bit of time. It can take a while to reflect, so just keep on refreshing, and hopefully once it's done, you should now see all this right here. So let's just refresh one more time and see if that's okay. So sometimes it can take a bit of time to reflect, so just be patient and just be assured that after doing this process, you don't have any information inside of our Neo4j database anymore. So let me just refresh this one more time. Okay, you can see now all that information is gone. So I can go ahead and close this. Now we have no information inside of us. If I click on this, it's just an empty, right? So an empty Neo4j Aura database instance, right? Good. So once we have that running, so now let's go ahead and set up the ETL directory structure. So this is the directory structure the directory structures you're going to be go ahead and use. So in the last video, we had this file called ingest, right? So ingest.ipynb, which is just a Jupyter notebook. So I also have another file in here. So just ignore this file for now. What we mostly focus on, we have all this from the last video as well. What we mostly focus on is this Docker compose file and the ETL pipeline folder, which has a Docker file, the entry point.sh script, bash script, and also the main ETL _py file, which is going to house all our code for the ETL process, right? Okay, so let's go ahead and actually set up that. So I'm going to go in here and I'm going to go ahead and say ETL underscore pipeline pipelines. I think I called it ETL pipelines, right? So I need to go ahead and rename this, and I'm going to rename this to be ETL pipelines, just like that. Okay, so in here I'm going to have a couple of things. I'm going to have a file. I'm going to have a Docker file. So Docker file. I'm going to have a main. It's called main underscore ETL dot py file, and I'm also going to have an entry dot sh file. So I'm going to say entry point entry.point.sh file, which is just going to be our bash script that you're going to be using, right? So once we have this done, that's all we need to do. And you also need to have a Docker compose at the root of our project. So at the root here, I'm going to create a file. Sorry, at the root right here, I'm going to create a file called docker-compose.yaml. Okay, so you can create either like this or like this, all work. So I'm going to use this right here. So that's all we need to do. So once we have all this done, let's continue. But that's all we need to do in terms of the directory setup for our project, right? So once we have that done, we can move on ahead. So we also need to install a couple of things. We need to install retry. We need to install Neo4j, and also we need to install pandas. Let's just install this to make sure that we have all the libraries installed. So I'm going to go back in here, open a new terminal, and I'm going to go ahead and then ls. I'm going to activate my virtual environment. Once I have it activated, I'm going to do a pip install retry. I'm also going to install Neo4j. Just make sure we have this installed already. So we also have pandas installed already, but I'm just making sure that we have that installed. So okay, once that we have that installed, I'm going to go ahead and simply update my requirement.txt file. So I'm going to say pip pip freeze, and I'm going to update the requirement.txt file. So once that's done, I'm going to go ahead and close this right here, and let's check the requirement.txt file to see if it has the reentry that the retry library that we just installed. So retry library, it helps us to basically whenever we call a function, sometimes the function can fail, right? So let's imagine that you have a code that is basically inserting data into Neo4j. Due to some connection or some network issues, that function might not work. So what it retry help us to do is to run that function again in case it fails, right? So we can run it 10 times, you can do it 20 times depending on how we configured our ETL pipeline. So that's basically what the retry package or library help us to do. So once I have it done, I'm going to go ahead and close all these other files. I don't need them. So what I'm going to be working with right now is this file right here, which is going to have a ETL pipeline, and I'm also going to bring in this right here. And basically, I'm just going to go ahead and use the code from in here to be able to just move the code from in here to inside of this file right here. That's what we're going to go ahead and do. Okay, so let's go ahead and see. So we also need to update our our env file to house the following file. So we're going to go ahead and add in the following into our our .env file. Okay, so you need to have this inside of your .env file so you can basically these are just paths to the different data that you're going to be using. So the different CSV files, just the path to them. Okay, so make sure that you have this inside of your .env file, and this is the .env file. I can't open it because it has my credentials at the moment. Okay, so let me just go ahead and update my env file so it has exactly this. So you can just pause the video and type it out. Okay, so I've just gone ahead and updated my env file to have this this code right here on the screen. So basically, now that you have done that, you are ready to move on to the next step. So the next step is writing the actual ETL Python code, right? Basically, writing the ETL script. So you're going to be using Python for this, and you're going to basically update this file right here. So if I go in here, you're going to update this file right here, which is the main underscore ETL .py file, which is under this ETL pipelines folder. Okay. So this file is going to update and it's going to do a couple of things. Let me just give you an overview what you're trying to do. Okay, so what you're going to go ahead and do, you're going to update this file right here. You're going to add in the ETL code, and then finally yeah, basically that's what you're going to go ahead and do. Just update this file to have the ETL code, and then basically make sure that it's actually working and running. So let's go ahead and actually implement the logic, the ETL pipeline logic inside of here. So this, I'm just going to let you know, this is going to take a bit of time. It's going to be a bit of a lengthy code. So sometimes just to speed things up, I may just copy the code that's already written just to save us on time. Okay. So the first thing we go ahead and do is just bring in the basic imports. So I'm going to go ahead and bring in the basic imports. I'm going to go ahead and import OS, and it's going to help us to set up our environment variables. So I'm going to also go ahead and import logging, and logging is going to help us to implement some logging. I'm also going to import pandas. I'm going to go ahead and import, let me just import retry first. Retry. This is say from retry. I'm going to import retry. So I'm going to say from retry import retry, just like that. I'm also going to go ahead and specify the font. So I'm going to go ahead and say from uh, dot env. I'm going to go ahead and import load env, and I'm going to say from Neo4j. I'm going to go ahead and import graph database. I'm going to go ahead and also import pandas as PD, just like that. So once I have that done, I'm going to go ahead and simply load in my environment variables. So I'm going to say load environment variables, and it's going to go ahead and load in environment variables. And I'm going to go ahead and go ahead and also I can go ahead and set in my file path. So I'm going to say load load file paths, just like this, and I'm going to go ahead and let me load the file paths. So it's going to be then just load the file paths. I'm going to actually get the code from in here just to save on time. So I'm going to go ahead and copy all this, and this we have already looked at in the very first video, which is just basically reading environment variables. Okay, so it's just using the OS mode, which is just imported right here, dot get env, and then these are the names of the environment variable. These are the names, these names right here in kind of like purplish color, right? These names are what you're specifying in here from our env file. Okay, so whatever you have used is in an env file for these names right here are the same things that you need to specify in here. Okay, so once we have that done, I'm going to move on. Let's move on to the next section, and we're going to go ahead and simply load in our Neo4j credentials. So when we say load Neo4j credentials, you're going to go ahead and import the, okay, just like that. And then let's see, yeah, that's basically what you're going to import. The URL, you're going to import the username. So this is going to be username. Okay, so I have it called username, so I'm going to say username. Also going to go ahead and import the Neo4j password. Okay, those are the credentials that I have instead of my env file, and you have looked at all this in the last video, right? So it's just the same thing that you're repeating in here. Okay, so once you have that, then I'm going to go ahead and simply say set in our setup logging. So I'm going to go ahead and simply say logging, and then you're going to go ahead and specify the base config. So in here, I'm going to go ahead and expand this more just to add in some more details right here. Okay, so I'm going to have a logging level, and then once I have a logging level, I'm also going to go ahead and have in a format. You can specify a format right here. Let me just make sure I delete this right here. We don't need this. So tap that. Let me just fix this. Okay, so yeah, that's basically the logging information we're going to have. So the format is going to be this format right here. We're going to have this format for logging, and basically also going to go ahead and specify the date time, and this is going to be, you can use this format right here. That's fine. Okay, so that's basically the logging, basically setting up our logger. So once we have this done, you're going to go ahead and create a logger object. So logger is going to be equals to, you're going to say we're going to say logging.get log, and then you're going to say underscore name, which is going to return to us the current running path, right, of this file. Okay, that's what underscore name does in Python. So we're going to go ahead and once you have this done, you have just done the basic setup. That's all we need to do for now, the basic setup. So now let's move on to writing the first part of the ETL pipeline, which is basically creating the names, the label names, right? So we have the different labels. We have the product label, the category label, the supplier label, the order, the employee, and the customer label. So let's go ahead and implement it. So I'm going to go ahead and simply say nodes. Sorry, this is going to be nodes, and these are going to be the following. So we're going to have product, so lowercase. So actually, this is going to be product, just like product. Okay, product, suppliers, category. Okay, let me just go ahead and just make sure that I break this onto multiple lines so that you guys can see all this clearly and well. Okay, so once I have this done, that's all we need to do. So let me just yeah, quickly format this, position it rightly, and I'm going to just tab this as well. That's all we need to do. So we have a product label, we have a supplier label, we have a category label, we have an order label, we have a shipper label, employee, and also the customer label. That's all we need to do. So now let's go ahead and actually create these labels. Okay, so to create these labels, you're going to have two main functions. So the very first function is going to go ahead and set the uniqueness constraint. So I'm going to go ahead and say create a Python function which say set underscore unique uniqueness constraint. And what this function basically does is that it's actually, you're going to go ahead and simply say create constraint on. Okay, let me actually just type this out instead of using this code that I'm getting provided in here. So we're going to get a query, and let me just change all this. So sometimes that will also work, but let me just write what I want to implement. So when you say query, it's going to be an S string, right? An S string, and you're going to go ahead and say the following. So I'm going to go in here and say the following. So this is going to be create constraint. Constraint. Okay, let me just have this right here, and then we can modify. So create constraint, and then if not exist. So create constraint, and then if not exist. So let me get rid of this part. So create a constraint if not exist on, and you're going to go ahead and use this. Going to be a product. So this is going to be node. So because we're going to pass in the node that's going to be passed in. So node, and also I need to accept node in here. So I'm going to accept node in here. So node, and that's all we need to do. So basically, create constraint on, basically right here, create a constraint if not exist. So if not exist for, let's use for, to make sure uppercase for, and then you're going to say n, and n is going to be the node. So let's use n right here. So we can use anything, but I'm going to be using n. So I'm going to say n and then node, and then we're going to go ahead and pass in this node. So this node is going to be something that's going to be passed in. So we need to actually, it's really a Python variable. Okay. So just once I have this done, and you're going to go ahead and simply say required n.id is equals to unique. That's all basically we need, and then we can close off this with a semicolon. So that's all we need for creating the constraint. Okay, so once I have, you can actually break this down into multiple lines if you want to, and that's absolutely fine. Okay, so once we have that done, I'm going to go ahead and say underscore is going to be equals to, because you're going to say xtx dot to run. You're going to go ahead and simply run that query right there. So just like this dot run, and you're going to go ahead and run that query. So we're going to have a query which is going to be create constraint if not exist for, and you're going to pass in the node name, right? And you're going to say unique, require that the id, the node, right? You say, because specify the node instead of, you store the node instead of a variable called n, but the node dot id is unique. That's basically what this does. Okay, so once we have this function created, we're going to have another function. We're going to call it create underscore unique. Okay, yeah, we need to say uniqueness constraint, and you're going to go ahead and simply run this function right here. So this function does not take in any driver. Instead, you're going to go ahead and set the driver inside of this code itself. So what you're going to go ahead and do is actually create the driver itself. So I'm going to go ahead and remove this. In fact, let me just remove all this that we have right here. So what you're going to go ahead and do, you're going to go ahead and simply say logger dot info. You're going to log information saying that creating, or let's say connecting to Neo4j. That's basically the logger information that we have, and you're going to go ahead and let's call this right here. So you're going to go ahead and pass in the Neo4j URI, and also going to pass in the auth information, which is going to be a tuple of the username and the user's password. Okay, so that's going to go ahead and create a connection for us. So once the connection is created, we can go ahead and use it right here. So we're going to go ahead and simply say logger. You're going to log another information dot info, and you're going to go ahead and say creating unique constraint. And that's fine. And you're going to say with driver.session as session. You're going to go ahead and simply say for node in this, you're going to simply say session.write. Let's actually change this. We're going to say execute write, and you're going to call this unique this function that we have up here, and you're going to go ahead and pass in the node that you want to create right here. Okay, so that's basically it. So this function, this might fail a couple of times, so we can actually just retry this. Okay, so we're going to actually wrap this in the retry, and we can retry for up to maybe 3 times, or let's actually change this to be 10 times. Okay, 10 times, and then in between tries, you're going to have a delay of around 10 seconds. So I'm going to go ahead and simply copy this, and then simply paste it here as well. Okay, so that's basically it. So once I have this done, I'm going to go ahead and simply save that code. So let me get rid of this S there. That's basically what we have to do, and this code is going to go ahead and create this unique constraint for us. Okay, so once we have that done, we can actually create an entry point and then try out if this are going to get created. So let me just go ahead and actually write a function, basically an entry point into a program that's going to be ran to create this. So instead def main, and then you're going to go ahead and do the following. So we're going to say creating unique constraint, and then you're going to call the unique constraint create unique constraint function right here, and then basically say unique constraint was successfully created. That's all we need to do. So I'm going to go ahead and create an entry point. I'm going to say if underscore name. And I'm going to go ahead and simply run the main function that we have right there. So that's basically what you're doing right here. Okay. So once you have this done, I'm going to go ahead and simply save this code. And once it's saved, you can actually run this code, and then let's see how it works. So before we actually run this code, let's actually go ahead and set up the bash script that's going to be the script that's going to be executing this code. So in here, you're going to go ahead and set the following. So I'm going to say this, and I'm going to say bin forward slash bin forward slash bash, just like that. So once we have this, it's called I think bang something, I forgot the name actually. So once we have that specified in there, it is going to say echo, and then you're going to go echo, and you're going to say starting ETL pipeline. You're going to go and simply say they are going to run the ETL pipeline. You're going to go simply run that file. So we're going to say in this case you're going to go ahead and simply say the following. So you're going to say ETL underscore pipelines, and then it's going to be called, this is actually main underscore etl.py. Okay, so that's basically, so ETL pipelines / main underscore etl.py. That's the Python function to run. So it's a Python 3, and then run this Python function, this Python file. Okay. So once we have this done, we are good to go. So now the next step we're going to go ahead and do is actually set up a Docker file that you can use, right? Which is this Docker file that we have in here. So I'm going to use a couple of following things. So we're going to say, we're going to use a Python image from which we're going to say Python 3. So we're going to use a Python 3.10 and not 3.7. So Python 3.10 slim. And we're going to say, we're going to set a working directory, which is going to be called app. You're going to copy everything. So we're going to copy all the requirements. So it's going to be dot / requirements. So dot / requirements. You're copying it into / app app requirements.txt. And then finally, you're going to go ahead and simply run the installation. Once we have run the installation, you're going to go ahead and copy everything from our current working directory into our working directory on the Docker container, which is the app directory. And then from there, you're going to go ahead and simply run the function. So I'm going to use a command. So I'm going to say cmd and then you're going to do the following. So instead of going to say, you're going to execute the bash script that we just created. So I'm going to say sh, and you're going to go ahead and run the following. So we're going to say / etl underscore pipelines, and then / entry point.sh. That's basically, so ETL pipelines, and you're running this bash script, which is entry point.sh script. So you're running that script. That's basically what you're trying to do in here. So we are running in the Python image. We're using the Python 3. Let's actually use the Python 3.11. That also works fine. So Python 3.11, our working directory is up. We're copying everything from requirement.txt file, which is this file right here, into our app / requirement.txt file. And the reason why I'm saying dot requirement.txt file, even though the Docker file is located in here instead of this folder, is because you're going to run this Docker file from this Docker compose file, which is located in the same place where the requirement.txt file is. So we're going to set the context of running this Docker compose file as this part right here. That's why I'm specifying dot requirement.txt. Okay, so that's a bit more of Docker and has nothing to do with our ETL pipeline. Okay, then we're going to install all the requirements. This actually I made an error right here. This actually needs to be / app / requirements.txt, and then finally copy everything into our app, and then finally we run this script right here, this bash script. That's all we need to do for our Docker compose file. So once we have it done, we need to go into our Docker file itself, and you're going to specify the following. So we're going to say version, and you're going to use version. We can use the following version. Sorry, the following version as a 3. Version. I'm going to say I'm going to use 3.8. Okay, 3.8, version 3.8. And I'm going to go ahead and specify the services. So services. Okay, so services, the first we're going to have is called, I'm going to call it Northwind underscore data underscore Neo4j underscore ETL. So you can give it any name that you want. It doesn't really matter that much. You're going to go ahead and say build, and you're going to build this. So we're going to specify the context as the current working directory, which is this dot right here. And this is the same reason why I'm saying that requirements is going to be from .env, right? The requirement file. because our context is going to be the same directory where the Docker compose file is. So we're going to run this, the Docker file, and we're going to specify which path the Docker file comes from. So we're going to say dot/etl underscore pipelines and then /Docker file, because our Docker file is located inside of this this folder and this file. That's what you're just specifying the path to that Docker file that you have created. That's basically it. And you're going to specify the env, because if you look inside of our script right here, we are using a bunch, we are reading these values from envs, right? So we need to load in our env, and that's what you need to go ahead and specify in. So inside .env file, and you're going to go ahead and specify the env file is going to be this env file, which is the same directory as our Docker compose file, right? So that's all we need to do. So once I have that, I'm going to go ahead and save this. That's and then we can run the script. Okay, so once we have this done, now let's go ahead and actually run this within the terminal. So I have my file in here, so you can see I'm in the same directory as my Docker compose file right here. So I'm going to go ahead and simply say docker -compose, and then we're going to say app -build, and then run that command. So it says there's no such file or directory. So let me just read through and see what we have. So it says that could not find this file, should not be in an ETL pipeline. Okay, so I don't know where this error is coming from, but ETL pipelines is actually called ETL pipelines. And let's just make sure it's ETL pipelines here as well. Okay, and here ETL pipelines as well. Okay, good. So let's try this one more time. Clear the terminal, and then let's run this one more time. Okay, so this is good. So it's going to go ahead and then install all the requirements, run everything, copy everything. I can see it's going to go ahead and install all the requirements instead of our requirement.txt file. So this can take a bit of time. So just give it a bit of time to install all these requirements, and then once it's done, we can go ahead and proceed. And right now, if I go back into our Neo4j, if I go back in here, and if I refresh this, you can see we have nothing currently inside of it. But once this ETL process has completed, we should now be able to see these labels being inserted in there. These labels with a unique constraint, because we just ran that part to insert those labels, right? So give this a bit of time, and then once it's done, we should be able to come back and then see all those labels being inserted inside of our Neo4j database. So let's just wait for this to get done. Okay, so the installations are done, and let's see how this goes. So it says so creating unique nodes, connecting to Neo4j, and then finally creating the unique constraint, and that actually went. So you can see now it says that unique constraint created successfully. So that's done. So now if you go back inside of our Neo4j graph database, and if I refresh, we should be able to see these labels be inserted. So you can see the category label, the customer label, the employee, the orders, the supplier, the shipper, and the product label. So all those labels have been created for us, right? So now we're going to go ahead. Now these labels have no nodes underneath them, they're just empty, right? So let's go ahead and actually write a code to actually insert those inside of it, to insert those actually the actual nodes within it. So it's the same thing we're going to be doing as we did previously in the last video. So I'm going to go ahead and simply copy the code and paste it, and then I'll explain to you for those of you who haven't watched the video from the last video. But if you've watched the videos from the last you have watched the last video, then you can tell it's just the same thing that I'm doing, right? So I don't want to waste your time over here and then do the same thing, right? Go through the same code line by line, explaining every concept. So now you can see these labels have already been inserted. So now actually let's write the code to actually insert these nodes within under these labels themselves. So to do that, I'm going to be actually using the code from the last video. I've just copied the code, modified it, and then turned it to functions, and then apply the retry decorator on them, so it can be retried X number of times. So if you watched the last video, then you can just tell it's the same code that I have. I have just turned it and cleaned it up, and then turn it into basically a standalone function on its own, instead of having it being in these cells within a Jupyter notebook, right? So if you have watched the video, then there is no point of me going ahead and explaining this all line by line. And if you haven't watched the last video, then you can go back and watch the last video in case you're confused about anything, right? They're all from the last video. So there's nothing new I'm doing right here. I'm just simply copying the modified code that I have. And you can also find this code on my GitHub repository. Link to that is going to be in the description of the video. So I'm just going to go ahead and copy the first one. So the first one we're going to go ahead and do, we're going to try to insert. We're going to do the insert the product, the category, and the supplier, just like the way we did inside of our ingestion. Sorry, in the ingestion dot Jupyter notebook right here. We did the products, the category, and the supplier. Right? It's the same thing that you're going to. It's the same, basically the same concept that you're doing. Right? So I have just cleaned it up and then turn it into a function. That's all we are doing. So I'm just going to go ahead and simply copy it right here. Copy all the way right here, copy all that, and I'm just going to go ahead and instead of in here, I'm going to go ahead and insert it right here just before the main function itself. So insert it right here. So what this function is going to do is simply read in the products data frame, the category data frame, and the suppliers data frame, and it's going to go ahead and combine all of them. And once it's all combined, you're going to go ahead and do some data cleaning on it, just like that we have done in the Jupyter notebooks right here. It's the same thing that you're doing, right? So same process, nothing new, same process. Okay, so the same thing. Data cleaning is the same here. Data cleaning is the same thing that you're doing, right? So once we did the data, we do the data cleaning, you're just going to return that data frame for it. That's all we are doing. Okay, and yeah, that's all we do. So I'm going to go ahead and save this. And now once we have the data basically cleaned, now we're going to go ahead and insert the data into our Neo4j database. And just like we did in the last video, we had a function that we're calling and then passing in some information, passing in each row of our data frame. It's the same thing we're going to be doing right here. So I'm going to go ahead and simply copy the function, and you can find all this in the link in the description of the video. So this is the same that you have done, right? You just write some cipher code. This function takes in some cipher code and then execute those cipher code. Same thing you have done, right? So that's it. I'm just going to go ahead and simply now call this function, which is actually going to load in the data into our Neo4j database. So copy that, and I'm going to go in here and simply paste it in here as well. So paste it in here, and then you can save that as well. Okay, so once we have that thing, then this is just Neo4j user. Okay, so actually let me just go ahead and change that to be Neo4j username, and then I have to change it here as well. So username, and I'm going to go ahead and change it here as well as a user name, just like that. So that's basically what we need to do. So that's it. And yeah, this basically loads in the pandas data frames, takes in the product, the file paths, and then simply loads in those data frame, pre-processing it, combining them, cleaning the data, removing any values, and then returning to us the combined clean data frame. You're going to have this function which you looked at in the last video as well, which is just a cipher code, and that's going to go ahead and insert the different products, the categories, and the suppliers, and then also create the relation between the different products, suppliers, and categories. So each product can be part of a category, and a product can be supplied by a given supplier, right? That's just like we have in the last video. We have this function which is going to be loading the data, basically inserting the data into the actual Neo4j database, and it takes in the clean data frame and then basically connects to Neo4j, creates a driver object, and then simply executes the code, basically calls this function right here, calls it, and then passes in each row of our data frame, and from each row we're going to extract information like the title. And you have looked at all this in the last video, right? You have looked at all this in the last video, so it's just the same thing that we have. It's nothing new, just the same code, right? So if you ever watched the last video, you can go back and watch the last video. It has all these details, so all this column information are all extracted from this table as we had in the last video. So it's the same thing. So if you have watched, there's no point of me explaining all this line by line, okay, because it's all in the last video. You can just go back and watch the last video in case you feel lost anywhere. Okay, so once we have this done, we are ready to go. So we just go ahead and just run that. Let's also go ahead and just do that. So we're going to say logger. This is going to be logger processing product category suppliers data, and you're going to go ahead and just simply load that information. You're going to go ahead and say data processing completed, and then finally you're going to go ahead and simply insert that data. So you're going to say load. You're going to load that data, suppliers graph data, and then you're going to simply load that data into our Neo4j database. So I'm just adding a logger right here. So let's say logger. You're going to say loading product categories into Neo4j database, and once this is done, you're going to also going to display the logger information again. So logger, and you're going to simply say data loaded successfully. That's basically what you want to do in here. So that's all we want to do. So we're going to go ahead and process the data, what this function does. So product data frame, it loads processes the data, right? So process the product, the category, and the supplier's CSV files. We pass in the product, the category, and the supplier's CSV files. Once we have that, you're simply going to go ahead and simply let the user know that we are done processing that. You're going to go ahead and simply load in the data into Neo4j, where you're having the loading function, which is this function right here. And this function calls the insert function and passes in each row information in a dictionary format. And you've explained all this in the last video, right? So goes ahead and insert all the data. Once it's done, it's going to let us know that it's done, right? So once we have all that done, I'm going to go ahead and simply save this, and then we can go ahead and run our Docker compose. Let me just bring it down again. So I'm going to say Docker compose. I'm going to say down just to bring it down, and that's how you bring it down. And let's bring it back up again. So it's going to go ahead and skip the installation of the packages step, because we already have the package already installed. And if you understand how Docker works in terms of creating these different layers, you understand what I'm talking about, right? So it's going to go ahead and create a unique constraint connecting to Neo4j, and basically going to go ahead and insert all that data in there. Okay, so you can see the reason we're getting this output because the unique constraint already exists, right? So that's why we're getting this kind of verbose warnings. Okay, so because we say create it if it doesn't exist, but if it exists, you just keep it, right? So you can see right here we have reached the point of loading the products category and suppliers data into Neo4j. So that's basically what it's doing right here. So it's loading the data into Neo4j, and it's calling this function and running this function. After that, it's going to go ahead and say inserting data into Neo4j, which is part of this function, which is inserting data into Neo4j. So it's actually running this part of the code. And once it's done, it's going to tell us data inserted into Neo4j, and you're going to go ahead and return data loaded successfully. Right. So let's see how it done, how it goes. And you can see data loaded successfully, data inserted into Neo4j, and then data loaded successfully. So all done. So that's all done. So if I go back into my Neo4j our instance right here, and if I refresh this, keep an eye on this number and this right here, so you can see we have some new relationships and some nodes have been inserted. So if I go ahead and click on the suppliers, it should be empty. Okay, the suppliers you have there, because if I click on orders, it should be empty because we haven't inserted any order at the moment, right? So if I click on this, we should be able to see all those records. And if I view this, right, so you can see our ETL pipeline is working just fine. Awesome. So once we have this running, good, we are good to go. So now let's go ahead and actually finish up with this ETL pipeline, and let's write the code to insert now for the remaining part of the code, so which is the suppliers, the orders, the order details, the customers, the employees, and the shippers, right? We need to write the code to the ETL pipeline to deal with this these sections right here. So again, all the code is as in the previous tutorial. As you can see, it's just the same thing we are doing. It says that we have cleaned everything up and have it inside of a function. So the first thing we need to go ahead and do is to find the function that simply loads in the suppliers, the other information, which is this right here, right? So I'm just go ahead and copy that function and then copy all of it right here. So I'm going to go ahead and simply copy all this function. So copy all that, and then I'm going to go ahead and simply add it just on top of the main function. So copy and paste that in there. So this basically loads in our information. So I need to get rid of this f string because you're not using any placeholders in there, so kind of like a variables in there. So that's basically what you're trying to do. So our driver connects to it, and then it says that you're not using this driver instance anywhere, so I can just simply get rid of it as well. Okay, so yeah, that's basically what we need to do. So I'm just going to go ahead and just get rid of this right here. So we're just reading our data, which is just loading in our data orders, data frame, the order details, the customers, the shippers, and also the employee. Do all the pre-processing as you have done in the last video. It's just the same code, nothing else, nothing new. Okay, so you can watch that video from the last tutorial if you haven't watched that. It's just the same thing, so it's nothing new. That's why I don't feel like explaining all. I don't think it's important to explain line by line because it's the same thing that you're doing. Probably just be wasting your time. Okay, so that's basically what this function does. Okay, load in the suppliers data frame, sorry, the orders, order details, customers, employees, shippers, load in the data, cleaning in, combining, and then return to us the process data frame. So once we have this done, we're going to go ahead and simply find a function that simply loads in loads the data in. So the first thing we need to go ahead and do, we're going to have the function that simply insert the manager record. Okay. So inside the manager record is going to be calling a function called create manager. And this function is a function that we have all the way above here. So if I go ahead and this function right here, so we need to have this function first. So I'm going to go ahead and simply copy this function, copy it, and then simply go back in here and then simply paste it in here. And you've talked about why we need to create the manager first. And we have talked about all this in the last video. Okay. So if you haven't watched the last video again, I can stress this enough. Go back and watch the last video in case you are getting confused any part of the video. Okay. So once we have that in there, we need to actually go ahead and we have this processing done. And also let's go ahead and also copy this, which is just inserting the record into our Neo4j database. And for this, I also want to add in the retry right here. So I'm going to use the decorator retry, and then just passing that. Yeah, that's basically it. So we're going to create a connection to Neo4j, and then finally get the vice president's records, and then insert the vice president records into our Neo4j by calling this function which you have above here. And I've explained all this instead of the last video. Okay, so again, just watch the last video in case you're getting confused any part of this video of this tutorial. Okay, so once we have the manager information being inserted, now let's go ahead and insert all the other records as well. So I'm going to go ahead and simply copy all this. So all this, just like this, copy all this right here. Okay, and copy all this. And once I have that, I'm going to go ahead and paste it in here and then save that. So that's all we need to do. So again, you have explained all this cipher code and what you're doing in this cipher code in the last video. So you can always check back the last video. I've just copied the function. I just copied the code from in here. Which if I scroll all the way down here, scroll all the way down, scroll all the way down, all the way down. So it's the same thing. I have copied it. I've just pasted it in here, just turning into a Python function, okay, to create a certain section of our ETL pipeline. And that's basically, and we have this load function, which is going to load in the data into our Neo4j database. Okay, so now we have that done. We're going to say logger, and this is going to be processing this. You're going to go ahead and process that information. So they have the order details, the customers, the shippers, and then the employees, right? So once we have that information, we're going to go ahead and simply say inserting data into Neo4j, and we're going to go ahead and insert manager records. And we talked about why we need to insert manager records first. We're going to go ahead and simply load in the orders, the details afterwards. So that's basically it. So that's what we need to do. So we're just going to insert the manager information first. And I've explained why we need to insert the manager information first, because there are other nodes that are referring to this manager node. So the manager nodes need to exist first. That's why we need to do this. And I've explained all this in the last video in depth. So you can check out the last video in case you have anything that you need clarity on. Once we do that, you're going to go ahead and insert loading the order details, the shippers, employees, the customer's data. We're going to insert that into our Neo4j database using the pre-processed data frame that we have done some pre-processing on. So once I have it, I'm going to go ahead and simply save this code. And once I have this code saved, we can go ahead and bring down our Docker container again, clear this terminal, and I'm going to go back in here, and I'm just going to go ahead and clear my Neo4j instance. So just reset it, because now we have the whole pipeline built. We can just reset it, delete everything from it. So let's check if everything is deleted. Again, it can take a bit of time to reflect. So just give it a bit of time. And we make sure that everything is deleted, because now we're going to insert all the records. We don't want having any duplicates in it. That's why I'm having to delete all this. Okay. So once we have everything deleted, and then we have a clean one. So we're just going to go ahead and run this one more time. Okay. So you can see now we are creating the unique indexes, connecting to Neo4j, inserting the data in, reading the data, and it's going to go ahead and inserting all the data. So merging the product information, cleaning the data pre-process, successfully loading data into Neo4j. It's going to go ahead and complete all these processes. And then once it's done, we should be able to see all those labels and nodes in here. So if I refresh this, we should see some information. Okay, so if you just keep on refreshing, this value should keep on changing, because each time ETL is running, the data is being inserted. Right? So more relationships and more nodes are being inserted each time. So just give this a bit of time, and once this is done running, that's basically our ETL pipeline. Okay. Yeah, and one thing I forgot to mention, if you're running this on your own, it might take a bit of a longer time to do because this record right here is actually very, very long. It has a lot of records to be inserted. So you can actually just filter this just to maybe just insert the first 250 instead of having to insert all of them, right? So that's one thing you can do. So since we have this running, then I have to go and actually stop this, okay? Stop this at the moment. And then I'm going to drop that, so once I have our Docker container, Docker compose down, now I'm going to go ahead and just clear this. I'm just going to clear this again. So let's just make sure there is connection. So let's go ahead and say, let's say, let's try to refresh this. And I'm going to actually go ahead and just clear this and reset this again. So that I run this again, and I'm going to run the ETL to insert data into now a clean, fresh Neo4j database. Okay, so let's just wait for this to load, and let's just keep on refreshing because I just cleared this, so all this should be gone. Just a second. Okay, because the reason why I have stopped is because I don't want to insert all the records, right? Just to take a lot of time. But if you wish to insert all the records, that's fine. That's up to you. You can just go ahead and just wait for it to complete. But for me, I'm just going to go ahead and insert just the first 250 order details, shippers, and employee information, right? Just for the first 250. I don't want to insert all of them. So let me just refresh this. Yeah, now our the database is clean, and make sure that you're in here just using the first 250 rows of 250 records. So I'm just going to go ahead and simply Docker compose down. It's already down, and I'm going to use Docker compose up just to bring up back my Docker container. So once this is it's going to run the whole process again. So just give it a bit of time, and once this is done, I'll be back recording. So while this is done, we can actually move on ahead and start talking of what to be doing next. So we have written the ETL pipeline. You have written .entry point .sh .bash script. You have written the Docker file, the Docker already. So what are really these Docker files that we just wrote? So Docker files are used to define the instructions for building a Docker image. That's what a Docker file is. So for those of us who don't know what Docker file is, that's what a Docker file is. Just basically a set of instructions for building what we call a Docker image, which is a lightweight standalone and executable package that contains everything that is needed to run a piece of software, right? Include the code itself, the runtime, the libraries, the environment variables, and all the configuration. You can see we had the code in there, copy the code in there. We had the runtime, we had environment variables, and we had libraries and stuff like that, right? So now that you have to look at what's a Docker file. Now, what's a Docker compose file? So Docker compose file is a YAML file, right? Which we named it as a .yaml, right? Used by Docker Compose, which is a tool for defining and running multi-container container Docker applications. So if you have multiple containers that you will see in the future videos when you start working on the back end building asynchronous APIs for our basically our AI agents that are going to be using a GraphRAG application, we'll see working with multiple containers, and you can see how Docker composes and Docker compose files help with that. So that's basically what Docker compose is. It can help you to run multiple containers and stuff like that. Right, it makes things much easier to do rather than using a Docker compose file. Okay, so Docker file is just the image itself. Docker compose files helps to create containers which are actually instances of these Docker images. Okay, now that we have this done, we're going to go ahead and actually run how to query our Neo4j database. So let's actually check if it's done. Okay, it's still running. So in terms of querying the Neo4j database, when we start building our different agents in LangChain, we are going to create an agent that can actually write a cipher code given the schema. And you're going to see how we're going to retrieve the schema of our database as well. So we're going to have an agent that can write cipher code given the schema and the user query, which is in natural language, right? So if you trace out some of these scripts, you need to understand what the AI is doing, right? So that's why we're going to look at a bit of the cipher. So we're going to look at the basic queries. We'll look at filtering, how filtering queries work. We're going to look at aggregation, and also pattern matching, how to match patterns in using cipher. So that's the things that we'll be looking at. So let's just wait for this to complete. Once this is completed, we can actually go ahead and start writing these cipher queries. Okay, so we just wait for this to load in some more details in here. Okay, so you can see it's still loading in some more information. So let's give it a bit of time, and once this ETL pipeline has finished running or is completed, then we can actually begin to write some of this cipher code. Okay, so learning cipher is relatively straightforward. There's a, if for those of us who are not familiar with cipher, so learning cipher is actually very straightforward, and there are a couple of ways that you can use to learn cipher for those of us who are interested in learning cipher. So Neo4j cipher documentation, there's a new documentation out there, and I'm going to provide a link to that documentation in the description of the video below. You can also use the cipher query language tutorial, which I'm also going to provide a link in the description of the video. You also follow the Neo4j community forum, which is an online community for Neo4j. You can find other people right there learning Neo4j or using Neo4j. You can ask questions and get clarifications on different stuff, right? So that's basically it. So for now, you have been using this browser or online or cloud instance of Neo4j. So you can actually install Neo4j to run locally on your machine. So if I just go in here, I can show you I have Neo4j installed right here. I have it installed locally as well. So if you are interested, you can have Neo4j installed locally if you want to. Okay, so let's check if our ETL pipeline is done. Yes, and it's completely done, and we don't have any error. So I'm going to go ahead and simply bring that Docker down. So this do Docker down, and it's going to bring everything down and remove all those images. Okay, so once this is done, this is basically our ETL pipeline. So our data has now been inserted in here. So if I refresh this, now we have all our records being inserted in here. Okay, so one of the first ways you can actually interact with this is just by clicking on this asterisk sign right here. This is going to go ahead and show you all the different nodes. So if I go ahead and show relationship, it's going to go ahead and show the relationships, and it's going to return to me just the first 25, right? Limited to the first 25. So if you want more, you can actually just increment this value, and you can just click on this play button right here, and you can get more information being returned, right? Yeah. So that's basically how you can basically query your cipher database right here. So we have the different categories there, the different labels, so the category label, the customer label, the employee, the order, and all this, right? So each of these labels can have nodes associated with it. So if you click on a node on the left right here, you can see the node information. If I click on this node, this is a supplier node. The supplier has countries in country Japan. This is supplier's ID, the contact title, and all that information, right? So these are called properties of the node. So properties, this one right here, are called properties, right? Okay, so awesome. So once we have that done, let's move on to and let's try some basic queries to do something a bit complicated. All right, good. So let's go ahead and let's see what else we can do. So we can also view the table format of this. So if I go ahead and click on table right here, you can see the table format of all these records. So you can, this is a graph format. You can click on table, you can see the table format, and you can also click the row, and this is the row format right here. So yeah, so if you're actually coding, the table format is actually very helpful. So you can see the different properties and how to manipulate them and stuff like that, right? So this is just like Python. If you're working in Python, these are just like Python kind of like dictionaries, right? So yeah, that's basically it. So now let's actually write some queries ourselves to retrieve information about different stuff that we might be interested in. So let's write our first cipher code. So just go ahead, click on this section right here, and in here you can search for different cipher code. So let's run a cipher code that's going to return to us the top just 10 different orders. We're going to go ahead and simply use the word match. So what match is very similar to the way we have select in SQL. It's the same thing. So once we have, you're going to say match and then order and then colon and then the label name. You have the order label. So that's the label name. So this is just a variable that you're going to go ahead and use to store into information. So we're just going to use it just like that. And this is just a variable that stores the information that you're going to use that's going to be retrieved. Okay, so you can press shift and then enter just to go on a new line. And then from there you can go ahead and simply specify return, the return keyword. So I'm going to go ahead and simply say return and then just like that. So and then basically what you have done is that you're searching for the any node that matches the orders label. You're just returning them right there. That's all you're doing. So if I run this, it's going to return to me all the available orders, right? That's all the available orders, and we have 250 orders because in here, instead of our code, we enable only 250, right? That's why in here we have only 250 being shown. What if you don't want all of them back? You can also limit them. So you can say use the limit keyword. So you say limit, and you can limit this maybe to a value like maybe 10. just like that. So if you run this, it's going to return to you only the 10 information right there. So that's basically how it works. So let me just zoom in again, so that maybe these guys can see this a bit much clearer. Okay, so I hope this view is much better. That's basically how this works. So yeah, that's basically the first query that we have written. That's a very, very basic query. So you say you have a variable. So if you want to select the category, then you can change this to be category, and then simply return all the categories that match that. So just return all the very first 10 categories. If I click on this, you can see it's of type category. The label is a category. The label is a category, right? So that's basically it. Okay, so once we have that, let's learn about filtering using Cypher query. So in this case, what they want to do is to filter basing on certain things. So let me just go back into order, just like that. And once I have order right here, I'm going to go ahead and execute this code. It's going to return to me the first 10 orders. So let me just see if I made a mistake right here, order, and then let's run this code. So we have the order right here. So if I click on this order have a number, right? A unique identity. So let's use the order to filter to get orders that match this information. Order with an order ID of this. So I'm going to go select this, and I'm going to go press shift and enter to a new line. And I'm going to go ahead and simply say the where order dot order ID, order ID is equals to, and I'm going to go ahead and simply paste in what I've copied, which is this order ID. So basically selecting all the orders in which we are selecting order in which the order ID is equals to this amount, and you're returning it back here. Okay, I don't have to limit it because it's only one order ID that should match that information. So just going to go ahead and returning it. So let's run this and let's see what we get. So you can see we got back 3 order IDs that match that information, right? Yeah, that's basically. So you can see these 3 different orders have already ordered 3 times, right? And they have the same order ID. Maybe there's an issue. Maybe you should have done some bit of cleaning to our data more. But you can see that's basically how you can filter basing on a given value. Okay, now let's go ahead and do something a bit more intermediate, maybe a bit more complex. So what I want to do, I want to find so let me just use s, and the s is going to be a variable that's going to go ahead and stop all the shippers information, and you're going to find all the orders that were shipped by a given shipper, right? We see we have this order right here, right? So you're going to find you're going to find the shipper who shipped this specific order with this order ID, and you're also going to go ahead and find which customer ordered this thing. So that's basically what you're going to do right here. So enter something a bit complicated query right here. So don't get scared by it. It's actually fairly simple. So we're just going to go ahead and say shipper relationship is going to be equals to shipped by. So if you look into the relationship, you have in the relationships, you have the relationship shipped by. So yeah, so if you have more, sorry, this one right here. So you have the relationship shipped by. So an order can be shipped by a given shipper, right? So that's basically what you're trying to do right here. So say O, it's of type order, and you're going to go ahead and specify where the order ID is equals to 10248. That's basically it, which is this file right here, 10248, just like that, 10248. So basically you're getting the order that matches this information right here. Okay, so this actually needs to be instead of not square brackets, but actually just parentheses. Okay, and you're also going to find the customer who ordered this. So instead the customer is going to be customer. Let me just see if I get this right. So it's going to be customer, and this customer needs to have okay, let's actually call this actually be customer relationship. So customer relationship, and this is going to be customer ordered by. So we're going to use the ordered by relationship, and this has a relationship with the actually with, and then you're going to say C, and C is going to be of type custom. That's basically what you're trying to do right here. And once you have that, you're going to go ahead and just press shift and enter to go to a new line. You're going to say return. I'm going to go ahead and return the following. So I'm going to go ahead and return the shipper relationship. I'm going to return the order, the customer, and the customer relationship. That's basically what you're trying to do right here. So let me just explain this one more time. We are selecting an order with this specific ID, and then we are selecting that order. We are selecting a shipper who shipped that order. So the relationship between an order and a shipper is shipped by. That's what it does. This part of the code does, right? And then for each order, this order can be ordered by a customer. So the relation between an order and a customer is ordered by. So an order can be ordered by a customer. So once we have all that, we're returning the shipper information, the relationship type, which is for the shipper, and the order. Then you're returning the order itself, returning the customer, which is C, and also returning the relation between the customer and the order. So if I run this, we should get something very okay. That actually didn't work. So let's see let's see if I made any mistake right here. So the order ID is 10.20.28.4. So 10.28.4. That's awesome. And let's just look at this more closely. So we have an order right here, and the order. Okay, I need to bring this right here. So and the order has an order ID. So order ID of 10.28.24.8, right? And this order has been ordered by a customer, right? And then this order has been shipped by a given shipper. So let's run that. Let's run that, and we still don't get any information back. So let me just change this to be 129, and let's see if this should work. Okay, now we get back that information. So it looks like we had that 128 had an issue. Okay, so that you can see now it works for 10.24.9. So we can see an order, these two orders. So these two order, this way, let's start with this one right here. This order has been shipped by, so you see the order has been shipped by a given shipper, which is called Speedy Express. And this order has been ordered by, so if you look the ratio between these two, right, this order has been ordered by, ordered by, and then the name of the customer ordered that order, right? This order has been ordered by this customer. So ordered by, and then this customer. So ordered by, then this customer. So this customer ordered this, this product was ordered by this specific customer, right? And this order was also ordered by this customer, and this order was shipped by this shipper, right? And this order was also shipped by this shipper, right? That's basically how it works. So that's the relation between that we can use right here. Okay, so now let's actually write a bit. Let's go ahead and write a bit more query right here. So when you say match, you're going to say O, and O is of type order. O is an order, right? And this order has a certain relationship that we don't know, and this order is connected to a node that we don't have a name for now. Okay, so press shift and enter, and I'm going to go ahead and simply say return. I'm going to return O. I'm going to return, let's add in a where clause right here. So I'm going to say where order id is equals to 10.24. Let me use 10.24.9, okay, because we have that already done. So I'm going to go ahead and simply return. I'm going to return the order, the relationship, and also the node that is connected to. So what does this query basically, what is this query pointing to? So we are selecting all the orders. Basically, we're selecting all the relationships. Like we have an order right here. Let's say we have an order right here, which is 10.24.9, which is the same order right here. So we are selecting all the relationships, which is R, that are associated with this order, and all the nodes that are associated with it. So this node right here has these relationships, right, and has these two nodes connected with it. That's basically what you're selecting. So this node has two relationships, so it can be X a number of relationships. You're selecting all of them. You're selecting all the nodes that those relationships connect to, either from or to, because we didn't specify the direction, right? So if you specify the direction, then it's going to return to us. For example, if I go ahead and say two, if I specify a two relationship, it's going to return to me only the ones that are connected to a given node, right? Basically originating from this node to another node. But since I didn't specify that, so it's going to return to me all the relationship that either come from, because a product can be part of a given category, right? So it's going to return to me all the nodes all the relationships that come from this node or come to this node. So like come from, like pointing away from it, come to pointing towards it, right? So it's going to return to me all those relationships along with the associated nodes. That's what basically does. So if I run this, so you can see you have all that right there. So you can see we have the pointing to and pointing away from. But if I go ahead and change this, and I change this arrow to be a pointing to, and if I run this code, we still get the information back. So you can see now we're only getting the pointing to, the pointing away from, pointing away from, pointing away from, right? Yeah, that's basically how it works. So if I run this again, yeah, we can see now we only, for actually this happened by instance that we have only pointing away from relationships. So you can see if I zoom in right here, you can see we have this different nodes right here. Yeah, so that's basically how this works right here. So if I minimize this and then minimize this as well, you can see now it's bigger. So you can actually close this if you want to. You can see it's actually now much bigger and clearer to see. Yeah, so that's basically a bit of a complex query to write. Okay, and I hope it actually makes sense right here. So once we have that done, let's write something actually a bit more complicated. And for this, I'm just going to actually let's try to write it together so I can explain this much more. So I'm going to go ahead and simply say match, and I'm going to say S, and S is going to be a shipper. And this shipper, we are going to go ahead and, okay, it's disconnected for some reason. Let me see again. So switch connection. Let's just say this and let's see connect. So sometimes it happens that you get disconnected. So just give it some time and then it will reconnect again. Okay. So once we have that done, I'm going to go ahead and do the following right here. So you're going to say a shipper relationship, and this is exactly what we did in the previous part. So it's the same thing, right? So order, and then be order, and then you're going to go ahead and specify, and you're going to say I includes, right? An order can include some number of products. So we're going to say P, and P is a product, just like that. Okay, so once I have it, I'm going to go ahead and press shift and then enter to go on a new line, and I'm going to go ahead and say where s dot company name is equals to speedy express. Yeah, so let me, if you remember, we have a bunch of shippers, right? We have three main types of shippers, right? One of them is it's called Speedy Express. So this is the shipper called Speedy Express. So if I over this, and if I can see the company name right here, so if I make this bigger, you can see company name is called Shippy Express, right? So I'm going to find all the products that was shipped by Shippy Express to the country, to Germany. Okay, so that's what I'm trying to do. So, and I'm going to use end clause and the order dot shipped country. So each order has a ship country, like which country it was being shipped to. So we're going to say where the ship country equals to Germany, just like that, and then press shift again, enter to enter a new line. I'm going to go ahead and simply return. I'm going to go ahead and get a count of all of those products, and I'm going to say as. I'm going to give it an alias name as. I'm going to say shipments underscore to underscore Germany, and let me just close off that. That's basically what I want to do. So let me just run this cell and then I'll explain to you what it actually does. So here, let me just explain. Let's go through it in case I made any error. So we're basically getting an order. That order that was shipped by a given shipper, and that order includes a certain product. Like an order can include a certain product, right? So we're basically saying that the shipper, the name of the company to be Speedy Express, and the order dot shipped country, the ship country is going to be equals to Germany. So I got the spelling of Germany wrong. So Germany, just like that. So Germany, just like that. So Germany, sorry, it's actually Germany, just like that. That's what I want to do. So Germany, and the order, the country to which the order was shipped to should be Germany. You're returning a count of all the nodes that match this, and you're giving that alias name as shipments to Germany. So if I run this, we should see now information. So we have 12 shipments that were done to company that were shipped by Shippy Express to the country Germany. So we have 12 orders that were shipped by Speedy Express to the country German. Okay, So once we have that done, I actually can add more. So just press shift and enter, and you're going to go ahead and say order.freight cost. Each order has a freight cost. So that's basically what I'm trying to do right here. So I'm going to say order.freight cost. It's going to return to us the cost of the shipment. So I actually need to go out actually add a comma right here and shift and enter. So sorry, not a comma, not a full stop, but a comma. And I'm going to say order.freight cost, and I'm going to give it a name as freight. Okay, that's the spelling of freight. And you're also going to go ahead and specify the product name, which is this right here, product name. Sorry, my bad. So product name, that's basically it. And product name, you're going to give it an alias name. You're going to say as product underscore name. That's basically what I want to do right here. So let me just go ahead and execute this query one more time, and let's see the result that we get back. So good. So we can see the different products. So the shipments to Germany, one of those, because you have done this for each individual product. So the freight cost for each of those products, and you can see the product's name. So tofu has been shipped to Germany. I don't know what this has been shipped to Germany. This actually looks clear like German. So you can see all the products have been shipped to Germany, and they're different freight costs, right? So good. So that's all we can do. And if you want to aggregate this, you can actually aggregate if you want to. To aggregate it is very simple and straightforward. All you have to do is simply just get rid of this part right here, and you keep a semicolon right here, and you're going to go ahead and use the sum function that comes with Neo4j. So just say sum, and then wrap that into sum function right there. So once you have that, if I run this, it's going to return to me the sum. So this is a sum of all the freight costs for given orders that were shipped to Germany. So we have 12 orders shipped to Germany, and this is the sum of the freights of all those orders, right? Yeah, that's basically how you can find aggregation in using Neo4j, right? And you can actually view the different information if you want to, right? Okay, so once we have this done, yeah, you can just go back. I just want to show you something. So let's run this one more time. You have the information right here. Okay, that's absolutely fine. So now let's go ahead and look at the schema overview. So if I go back in here, now let's go ahead and look at an overview of the graph schema. So we have the graph schema so far, but what's really this schema? How does this schema really look like? And to do that, you can actually write a code to understand this schema, because the reason why is because this schema is actually going to be used by Neo4j. It's going to be used by Neo4j to actually sorry, not by Neo4j, by our graph agent to actually have an understanding of our schema, so that it can be able to write queries to answer the user's question, right? Converting natural language into cipher code, and then executing the cipher code against our Neo4j database, and then returning the result back to us, and or using the result to answer the question. So how does the LLM or the AI knows how to run the cipher? So the LLM knows how to run the cipher by understanding being provided, or by the AI understanding what's the schema of our graph database. So how do we print the schema out ourselves? So to print the schema out, it's actually very simple. There's a command for that. So let's take a look at how we can write the schema to the query to visualize our schema. So it's actually very simple. We can just say call, and then we're going to say db.schema, just like that, and then just basically just like this, and then close off this. So that's basically what we need to do. So once I execute this, it's going to return to me, okay, it says that we have an issue right there. So let's actually say let's say actually version 4. Okay, this actually changed probably a bit in version 4. So we have another command that you can use to actually visualize the schema. Okay, to do that, you're going to say call. Let's use a call command. So the call, and you're going to say call, and you're going to go ahead and simply say db, right? db.schema, and you're going to say .visualize, just like that, and then simply call this right here. Okay, once I execute this, let's see if you are now good. You can see the visualization of the schema right here, and you can see also the table format of how the schema works. So you can actually just see how all these things are. So you can see employees and employees reports amongst each other, and you can see orders are processed by different employees, orders are shipped by different shippers, orders are ordered by customers, orders are includes different products, and products can be part of a given category, and each product is supplied by a given supplier. So if you give this schema to an LLM, the LLM can know exactly how to write queries so if you give this schema information to an LLM, the LLM can know how to write queries to be able to answer the different questions. So it can convert natural language into ciphertext and then execute the ciphertext against our Neo4j database. And this ciphertext can only be written if the LLM understands the schema, and we provide the LLM with such a schema, right? So this kind of schema can help the LLM to understand which what property, what are the different labels, what are different properties of each of these labels, and all that stuff, right? So the LLM can understand all this information, right? So just looks like I got disconnected one more time. So let me just see if I can connect to this again. So connect, and let's see if that connection works. Okay, so that's basically how you can write different calls and then be able to visualize basically the schema of your Neo4j database. Yeah, so that's basically how all this works and how you can visualize all this the schema of your given Neo4j graph database instance, right? So that's basically all I wanted us to cover in this video. So you have learned about schemas, you have seen the schema overview, and all this you're able to visualize the schemas and all that, right? So I don't know why the call db.schema doesn't seem to work. I would have to, okay, I think this works for version 4. I think I am using a different version. That's why you're getting this error, but it should, in Neo4j, in Neo4j version 4, this actually works. I don't know why it's not working at this time. Because probably I have a different version. Okay. Anyway, the second command, the second command actually works fine, which is call db.schema.visualization, and we get the visualization back. Okay. So guys, thank you guys so much for watching. And in the next video, we're going to go ahead and continue with our GraphRAG series. In the next video, we're going to go ahead and look into building line the basics of LangChain. You're going to go ahead and look at what is a LangChain expression language. You're going to look at different chat models. You're going to go ahead and look at how to build agents in fast API in LangChain, because you're going to use all this knowledge in the other section of the articles. We're going in the other section of the video, where you're going to actually go ahead and build an agent to be able to interact with our Neo4j database, basically, right? Basically, which is a GraphRAG application. So for us to be able to write this agent, we need to be able to understand how LangChain works, right? So we're going to look at the basics of LangChain, and that's going to be in the next video. So guys, thank you guys so much for watching, and I hope you're enjoying this series. If you're enjoying the series, then awesome. If you want to follow me on other platforms, like if you want to read the articles about these videos as well, you can follow me on Medium at Prince Cramper, where I write articles about this video. So if everything you see in this video has a written article version of it, and you can follow me on Medium at Prince Cramper. On YouTube, you can hopefully, while you're watching this video, at Code with Prince. On Twitter, you can follow me at Prince_Cramper. On LinkedIn, you can follow me at Prince Cramper. So if you have any questions, any things that you need clarification on, if you have any project ideas that you want to build and you want to reach out to me for consultation or any sharing of ideas, and then just general discussion, you can follow me on LinkedIn at Prince Cramper. I am much faster to reply to you through LinkedIn. On email, I'm very slow to reply to you. You might never even get my reply back, sorry, but you can always find me on LinkedIn at Prince Cramper. I'll reply to you very fast. So follow me on LinkedIn in case you have any questions, any suggestions, any recommendations, just want to discuss something, get some clarity, or just consulting on something. You can follow me at Prince Cramper on LinkedIn. Okay guys, thank you guys so much for watching, and I hope you found this video helpful. If you did, don't forget to like the video, to share this video with all your friends and family who you think might find value in this video. And if you want to support me further, you can also buy me coffee. The links will be in the description of the video. Thank you guys so much for watching, and see you in the next video. Keep safe.